In this video, I'm going to review the examples that you were asked to do, which involved dividing numbers with different bases. So when we do division, it gets a little bit more complicated, and which is why, in some cases it actually may even be a circumstance where it might be even a little easier just to convert the numbers into base 10 and carry through the division and get your answer and write that in, back in the base you're looking at. But even with that, I mean, most of the division, they're not going to ask you to go beyond a single digit on the outside, so it's not too bad. But the way you would start this off is, I mean, this one's not too bad because no matter if I'm in base 8 or base 10, 2 can go into 7 a certain number of times. And I have a list of some, multiples, and obviously 2 base 8 times 3 base 8 would get me the closest to that 7, so obviously I want to put the 3 up here, base 8, and do my multiplication, carry through the subtraction, and so I get a remainder of 1, which I go down to the next digit, I bring down to 3. Now, I know that 2 times 4 is 8, or 2 times 4 is 8, which is 10 in base 8. If I go up a couple more, I have 2 base 8 times 5 base 8, which is 12 base 8, which is even closer to this number. When I do 2 base 8 times 6 base 8, I'm at 14 base 8, which is over this number. So the number I want to put in next and multiply by 2 base 8 is 5 base 8. And so it's going to give me my 12 base 8. When I carry it through the subtraction, I'm going to end up with a 1. I'm going to bring down to 0 base 8. And now I have 10 base 8 divided by 2 base 8, which we can see here would be the result of multiplying 2 base 8 by 4. And that would be the solution to this. So you have to make sure that you are keeping track of what base you're in and not automatically go in your division with base 10 circumstances. And that's where it gets a little tricky. So next one, 214 base 6 divided by 5 base 6. So again, I'm going to list some powers of, or multiples of 5 base 6. And as you can see here, if I do 1 times 5 base 6, I get 5 base 6. So I do 2 base 6 times 5 base 6, I get 14 base 6. And when I do 3 base 6 times 5 base 6, I get 23 base 6, which is a little bit over this 21 base 6 I have here. So obviously, I want to multiply this 5 base 6 to 2 base 6. So I'm going to put the 2 up here, which is going to give me the 14 base 6. And when I subtract them, 21 base 6 minus 14 base 6 is the same thing as me doing 13 minus 10, which is 3 in base 10. And 3 in base 10 is the same thing as 3 in base 6. So I'm going to have that 3 there. So you do have to make sure that you are subtracting using the bases that we have worked with. And then to bring down the 4, leaving me a 34 right here. So I'm going to see if there's any higher numbers, any higher multiples of 5 base 6 that I can use to go into 34. So 4 times 5 base 6 gives me 32 base 6. And as I can see here, I mean, it looks like each time that I go from one base 6 value to the next, it looks like I'm going up by 9. So I'd almost expect that 5 base 6 times 5 base 6 would probably be something along the lines of 41 base 6. So that certainly would be over. So 32 base 6 is where I would like to be at this point. So I am going to multiply this 5 base 6 by 4 base 6. Well, you see the 41's right there. Leaves me a 32 base 6 with a remainder of 2. Now there's no more numbers here. So I would write this with a remainder. I would say that this is 24 base 6 with a remainder of 2 base 6. Moving on to the next one. So I have 2,101 base 7 divided by 3 base 7. So for this one here, 3 does not go into 2 evenly. So I'll be looking for 3 to go into 21. But I do have to remember these are in base 7. So I'm not going to be able to simply say here, well, 7 times 3. I got to figure out like what multiple of 3 base 7 is actually close to 21. So I start making a list. And as we can see, 3 base 7 times 5 base 7 is 21 base 7. So it's a little bit different than many people think on that one. So when I want to get the 21 down here, I am going to multiply this 3 base 7 by 5 base 7. That's going to give me the 21, and when I subtract it, it's going to give me the 0. I would then bring down the 0. Well, I have nothing here still, so just bringing down this next number doesn't really help me a whole lot. So I'm going to just put another 0 up here and bring down the next number, which gives me a 1. Now that's the last digit I have, so there's no other numbers to bring about, and they certainly don't go into how to deal with decimals, because decimals would even work very differently in a base 7 system, because you'd be dealing with sevens, 49ths, things like that, and we don't want to get into that too much. So basically, 3 is not going to go into 1 at all, so I'm going to have another 0 here. Multiplying that through, I get a 1 as a remainder. So my answer would be 500 base 7 with a remainder of 1 base 7. Moving on to the next one. Now I threw a couple of examples on here with bases of 12 and 16, although you're not really asked to do a whole lot of this. So just want to demonstrate that this could be done the same, but it does get rather complicated. So if you would be given a problem like this, that you had a base over 10, it probably would be beneficial for you just to change the two numbers into base 10, carry through the division, and then get your answer in base 10 first, and then convert it back over to base 12. Because when I look at this situation here, 9 does not go into 7 evenly. 7 is smaller than that, so I'd be looking at 73, but that's 73 base 12. And 73 base 12 is not the same thing as 73 base 10. So I need to start considering multiples of 9 base 12. As you can see, I go through quite a bit of a list here until I actually got to a place where I could definitely state that, I found the best multiple to put in there, and it would be 9 base 12, because that gives me 69 base 12, whereas a base 12 times 9 base 12 would give me 76 base 12, which is too big. So that means I could put my 9 up here. 9 base 12 times 9 base 12 is 69 base 12, which I would then carry through to subtraction, which I still have to be careful that I am subtracting in base 12. So when I borrow this 1 from here, I'm going to have 13 in base 10, but 13 in base 10 is 11 in base 12. So when I carry through the subtraction, minus 9 base 12, I end up with 6 base 12. And I messed that up. It's 13 is actually 15 in base 10. I was going the wrong way there. I'm trying to do it in my head too much. So I get a remainder of 6, which I then bring down to 0. As you can see here, I have some gaps here. I have 69 base 12 and 46. This seems too big. That seems way too small. So I'm going to see if I put something in between here. 8 base 12 times 9 base 12 is exactly 60 base 12. So at this point, I could put my 8 base 12 in here, get my remainder of 0. And so my quotient for this would be 98 base 12. And this last one here, I decided to put one in here just to kind of show like how you would handle this with base 16s and things of that nature, and dealing with some of the letters as well. But again, you're not going to necessarily be asked to do this a whole lot, so be aware of the fact that that's not a major concern. And it looks like one of the marks I have animated is coming through already, so I'm not going to go back and fix it right now. So I have AB 18 base 16 divided by C base 16. Now I have to remember, A base 16, B base 16, all the way up through F, where C base 16 is basically equivalent to a base 10 value of 12. A is equivalent to a base 10 value of 10. B is equivalent to a base 10 level of 11. So needless to say, when I look at, trying to divide A by C, I just can't do it. So I'm going to be looking at AB to divide by, C to the base 16. And again, I'm going to try to see, like, hey, well, you know, A times B base 16 is 171 in base 10. So I had to look for, like, a combination of, you know, a number being multiplied to C base 16 that gets me close to 171. And as you can see, I can have quite an extensive list, and involving the letters and everything, it gets even more complicated. That's why you're not going to be asked to do a division quite this severe in most circumstances. So, but I did want to show it just so you had a chance to see that it can be done. I would probably recommend on this one, it's probably easier just to convert these numbers to base 10, carry through the division, and then convert back to base 16. But anyway, as I go through this list here, you know, I have my base 10 numbers. It looks like the closest I get to 171 is 168. That's when I do E base 16 times C base 16. So I put that in there, and when I carry through the subtraction, I do get a remainder of 3, and that's in base 16 as well as base 10. I bring down the 1. So this is 31 base 16 now. Now 31 base 16, the closest number I have base 16 is this number right here, 30 base 16. So I want to multiply C base 16 by 4 base 16. And when I do that, I get the 30. Subtracting that, I do get the 1, which is why that was there. I then bring down the 8. So now I have 18 base 16 divided by C base 16. And as you can see here, 18 base 16 is actually a number here. 2 base 16 times C base 16 gives me 18 base 16. So when I work that out, that's what I get. And so the answer is E42 base 16.
And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.